This question is from strength of materials for 2 marks. In a UTM experiment, a sample of length 100 mm was loaded in tension until failure. The failure load was 40 kN. The displacement measured using the cross-section head motion at failure was 15 mm. The compliance of the UTM is constant and is given by 5 into 10 power minus 8 meter per Newton. The strain failure in the sample is. For this numerical answer type question, the accepted answer range is 2 to 4. Let's proceed to the solution. We are given with the sample length as L is equal to 100 mm, failure load as P is equal to 40 kN, and the displacement at the failure as delta is equal to 15 mm. Generally, it is to be noted that compliance is nothing but inverse of stiffness, and this value for this UTM is given as 5 into 10 power minus 8 meter per Newton. Generally, stiffness in strength of materials is written as AE by L. Therefore, compliance becomes L by AE, as compliance is the inverse of stiffness. Now, according to Hooke's law, we can write stress by strain is equal to Young's modulus. So from this, we can get the value as delta is equal to PL by AE. From this, we can rearrange the terms and get delta by L as P by AE. But we know that delta by L is nothing but strain, and P by AE can be written as PC by L. Now when we calculate PC by L, since we have failure load as P is equal to 40 kN, 40 into 10 power 3 Newton into 5 into 10 power minus 8, which is the value of compliance given, and length of the sample as 100 mm, that is 100 into 10 power minus 3 meters. Simplifying that will give us PC by L is equal to 2 into 10 power minus 2. But from the above step, it is clear that PC by L is nothing but strain. But in the question, we were asked to calculate the strain rate, that is strain in terms of percentage. Therefore, 2 into 10 power minus 2 into 100 will give us 2%.